Hello, everyone. In this lecture, we are going to look at the distance matrix computation. Okay, three different ways to do the similarity. We talked about we need similarity or dissimilarity. Measures. So here we are going to calculate the Euclidean distance. That is L2 long. So let's look at this this data set. We have observations. So here is our data set. And this data set, we have x11, x12, x13. So this first subscript representing the observations, okay? The index of observation. And the second index representing the index of the predictor. So this will be second observation, first predictor, and 2, 2, x23, x31, x32, x33. Now, this is a predictor because I didn't specify which observation it belongs to, so only for predictor. So I use dot. But when it comes to a specific element, for example, 1, it is actually x11. So this notation with an arrow on the top, this is a vector. Each observation, sample observation, is a vector. Okay. The data set, we use capital X, which equals to x11, x12, x13, x21, x22, x23, x31, x32, x33. But we could have n observations. And p predictors. Then this will become, if we have n observations and p predictors, this will become something like this. Let's redraw this one. And a general matrix will be like this: x1p, x2p, and then we have xn1, xn2, xnp. And each row is an observation. Each column is a predictor. And we want to find out the observation. Which row is, if we put it in this is a three-dimensional space. This is a p-dimensional space. We want to find out the clusters of our observations. Now let's have a look at D11. D11 is the distance between the first observation and the also the first observation, and this is 0, right? So distance matrix, we will have 0, 0, 0 in the diagonal. And then we are going to have, because this matrix is actually symmetric based on the definition of the similarity measure, we want something to be, so D12 equals to, because the distance between the first observation and second observation is the same as from the second observation to the first observation. D13 equals to D31. So in this way, we only need to calculate either upper triangle or lower triangle matrix. Now let's calculate maybe D12, D13, and D23. So this is a symmetric matrix, so we only calculate the upper triangle. Let's try to calculate D12. So we know that if we have two, then we will have x11 minus x21 squared plus x12 minus x22 plus x first observation, third predictor, not plus, minus x2, 3. And then we take the square root. So this will equals to 1 minus 1, this is 2 square. Because 1 minus 1, so it's 1 plus 1. Plus 2 minus 1 is 1 square. 1 minus 3 is minus 2 square. Square root, then this equals to 3. And same for D13 and D23. So in the end, we will get the distance matrix that is 0, 3, 3.74, and 6.71, 0, 0. So because it's symmetric, this will be 3, this will be 3.74, 6.71. Okay. Now, the Manhattan distance is also called city block distance. The only difference is this one is L1 norm. L1 norm. We're going to take the absolute value. So now let's still do the distance matrix. So this is 0, 0, 0, D12, D13, D23, right? Now we have these are symmetric. So D12 will equals to x1, 1 minus x2, 1. Now you have absolute value, okay? Plus x1, 2 minus x2, 2 plus x1, 3 minus x2, 3. So this will equals to 1 minus 1, this is 2, plus 1, then plus 1, right? Or plus 2, this is minus 2, absolute value is 2. This equals to 5. Then you can do the same thing for D13, D23. This will equals to, let's see, 0, 5, 6, and 11, 0, 0, 5, 6, 11. So this will be the distance matrix. Now Minkowski with L2 norm. L2 norm will be, okay. Minkowski, what is Minkowski's distance? If we have two values, so dx1 and x2, so two vectors, right? Now this will equals to the summation from I from 1 to p, xi 1i minus x2i. Then we are going to take the power of m and then take 1 over m square root. So since m equals to 2, this will be the L2 norm. But you can change m to different values and use this equation. And then what we get, the distance matrix is the same as the first one. That is 0, 3, 3.74, 6.71, 0, 0, 3, 3.74, 6.71. So here, this is the distance calculation. So we showed how to calculate L1 norm. This is L1 norm, L2 norm here. But most importantly, let's understand about the data organization and the observations and the predictors. Sometimes people this general data format. Okay. Please note in clustering we don't have y, we only have all the x. So that's why it's called unsupervised. You don't have target. So this is the end of this lecture.